Alright, I may wait like one more minute and then I'll start going through this stuff again. I'm just going to go ahead and start. If you're here, just put like a period in the chat box for me. Kind of let me know who's actually hanging around. Okay. All right. So we're just gonna pick up on this video, or pick up with R. So we're gonna slowly transition from using R in kind of a generic way to using R for what it's good for. Right, so I'm going to start a new script. So I'm just going to go. I'm not going to play around with this playing script. I'll make a different. Script to start playing around with. And I'm not going to mess around too much with this terminal console part. I'm going to leave that alone largely and kind of just work within the script itself. So before I do anything, I'm going to change. Remember, I'm going to change my working directory because right now it's just kind of in this default state or default place. It's looking for R packages or text or something else in a directory that I don't want it to look in. So I'm going to change my working directory to where I want it to be. Right. So this is on my desktop, and I'm just going to go to test2 on my desktop. Right, that's where I had the other example. Right, nothing's in there. I'm just, or it looks like nothing is in there. I'm just selecting the directory I'm going to work in. Okay, so I changed my directory. I'm going to start a new script because all this stuff, I think if I keep working in this, it's just going to get cluttered and kind of gross and a little awkward. So I'm going to leave that alone and just start a new script. And so I recognize that this was brought up last time that in a new script I can still have my old script present and also be able to work on a new script. And so I could theoretically save this now to start messing around with it, or mess with it and then save it. Either way, it doesn't really matter. I'm just going to go ahead and start saving it, and I'm going to call it. I don't want that. I want to save it. I'm going to call it data frame test, or df test.r. Because what we're working with today is data frames. I think two things that I want to cover today, I should say, are data frames and importing packages, because that's how R starts to get really, really handy, is working with the data frame. And I haven't defined a data frame yet. I'm just going to go ahead and comment this out real quick. 129. Okay. So this first example, I'm going to build a very simple data frame just so that this is defined. Okay, so a data frame is very similar to a spreadsheet in Excel, right? It's effectively the same thing, just a generic spreadsheet that we can start manipulating. But the better you get at R, the more you can manipulate and the faster you can do it. So first of all, I'm going to start building a data frame. It's going to be very simple. It's going to be very stupid. But we'll build up to this. We'll build up to doing this for, I guess, more or less real life. So first of all, I'm going to set a few vectors. I'm going to define a handful of vectors that are somewhat related to each other. So for example, I'm going to build a database about person information. For example, so I'm going to build a vector about a person's name. So I'm just going to set a vector and recognize, so R is fine with working with texts. However, if we're going to manage and manipulate text, we have to use our parentheses. And it doesn't matter if you use a single parentheses or two parentheses, it doesn't matter. I'm just going to fill this vector with random names. And Kate, why not? And so recognize it doesn't matter if I do single quotes or double quotes. R will treat it the same. It doesn't matter as long as a double quote, an open double quote is closed by a double quote, or a single quote is closed by a single quote. It doesn't matter as long as everything's consistent. And now I'm going to make another vector that's going to contain the ages of these individuals. So I'm going to do age is equal to C, and for integers it doesn't matter. And 17, why not? Young people. And then we're going to provide their sex. So again, we're working with text. And I'm trying to keep everything straight. So Mike is age 10 and a male. Josh is age 20 and also a male. Oh boy, I've done something. Okay. Right, so everything's reasonably consistent, and I have my two females. Okay. It's not exactly handy to work with independent data or independent vectors or independent strings, whatever. It's a little bit of a pain to do so. Real quick, I'm just going to load these in. I'm just going to highlight, Control Enter, so those will actually run and those get defined. And now I'm going to make a data frame. And to basically paste these vectors together into a single object can be done with data.frame. And so in data.frame, what I'm going to do, let's see if I can help me real quick. And so data.frame, it basically is that within the brackets, within this function, within this data frame function, I can provide my three vectors, and data frame will effectively stitch them together. So if I just do this as is, this isn't very. I'm going to do name, sex, and age. And so whenever I run this, it's going to return a vector. It's going to return a data frame, or effectively a matrix. Right, so now I have my name, sex, and age as a data frame, as effectively an Excel sheet or a spreadsheet. But I need to save this like persons. Okay, so now the really great thing about RStudio that's a huge advantage over R is being able to actually look at your data frame after it's been loaded, right? So I can come over here to my environment, click on persons, and it's going to basically give me that spreadsheet of the person's name. On the same row, we'll have their sex and age. Nice. Right, so this isn't necessarily practical in what I'm doing. It's just rare. Sometimes you have to make your own data frame from scratch. Most of the time you don't have to. However, also with this data frame, with using this function data frame, so recognize that my column names are defined based off of how they were stored. So I have them stored as name, age, and sex, and and so my column names are age, name, and sex. But I can change that. I can make R do that a little bit differently. So I'll do person B. Where I can set, say, my column name. I can define my column name as in is equal to names. And the reason I'm just picking these letters is to show that it will be different. The column names will be different, and I can define those column names different from what the vector name is. And I'll just do it in a different order. S equals sex and A equals age. Why? What have I done? Cannot class function to a data frame. I've done something stupid, I don't know what it is. Function to a data frame. Why can I not do this? Mistake, misspelling. Hopefully that's it. Aha. Yay. So I had names, and I had this as names, and names is its own function. Yep, name, not names. Yep, my mistake. And so names is an actual function, but even that is, I didn't call what was defined. And so R is going to give me a complaint. R did give me a complaint and said, I don't know what you're saying because you haven't provided me anything named names. And so it gave me a hiccup. And you're going to run into a lot of hiccups. Honestly, it turns out, I mean, you get better at this by basically figuring out what all of the errors are and what all of the errors mean to avoid them. And that takes longer than anything else is. Avoiding errors. Anyways, persons 2. Okay, and so persons 2, there's persons, and so recognize I can have persons and persons 2 up here that I can sort through and look through, right? So persons 2, I have my names defined as N, S, and A. Right? Again, I can choose. If I don't want my column names to be associated with the vector I made, I can create those independently. So I can define what my column names will be. Nice. Okay. But usually, as I mentioned, I think it's reasonably rare for me to make my own data frame. It's more common for me to import a data frame. So I sent out a file for y'all to play around with that I can use as an example. So if I want to read data, basically a spreadsheet. So let me open that real quick so we all know what I'm kind of looking at, what we're looking at. And so what this text file is, I could certainly as easily open it in Excel if I wanted to. But what this is it's data from the National Center for Education Statistics that are basically math scores from each state, or like a mean math score from each state of 8th graders, right? So I think this is derived from a standardized test, and then we have the state, a state symbol, this general score, like a mean score of that state, and how well that score is relative to, how many students, what percentage of students did at least a basic proficiency on this exam, right? So this is basically math scores associated with every state. And recognize I have every column already defined. So I have a state, symbol, score, and percent at or above basic. Okay, and so I'm going to load this file into R so that R can read it. And I went ahead and already put this file into the same folder as I defined. It's in test 2, right? So where I defined, or where I told sessions to start looking around in, right? I said okay, and so whenever I want to read this file, how I call that is the function for that is read.table. So read.table, I can call a certain file, so I can call that file, if I put it in double quotes, if I just try to test that out, if I just try to write that out, I think it's state math, right? I can't pull it up. But if I put it in quotes, do state math, it's going to autofill for me because R is looking in this directory for things that I'm typing. So I'm going to read.table, call my file name. Now, if I just load this in state math. So if I just load this in now, it's probably going to be kind of ugly. Why? Line 2 did not have 9 elements. Yep. So it's complaining. R is complaining. R is complaining because I have spaces, I have white space in my headers, in my column names. So I already have to address this. So I have to tell R that my columns are separated by tabs. Let's see. Yes, no complaints there. And so this \T it's a computer symbol for tab. Now, so this is partially why I don't necessarily like being public, because I'm going to do things in ways that aren't necessarily, they're probably more cumbersome than they should be. So for example, I like tab delimited files. Right, so my columns are separated by a tab. Almost everybody else likes comma separated files. So instead of a tab being present, all of this would be on one line, no white space, and separated by a comma. Right, so that would be a comma delimited file. I'm not going to save this. And R works fine for both. It's probably just a little bit more cumbersome and maybe slightly more risky to use a tab delimited over a column delimited or a CSV. But Excel will export both, so you can make Excel export a tab CSV. It really doesn't matter. It's just sometimes you might run into some more problems with a tab delimited than a comma. But nonetheless, this is my tradition. Sometimes my traditions don't make sense, but nonetheless, this is what I learned, and this is what I do. So I'm just defining how that, how my data is, how I know I'm in a different column. So, but the thing is, if I bring that up, so state math, my column names are very stupid. So like V1, V2, V3, and my actual column names are part of the data frame. Because by default, read.table assumes that you don't have columns defined. But I do. And so my column names are header. or head or header, doesn't matter. But if I set my head equal to T, that means so that means, I'll get there, Nick, hold on, that I do have a predefined header, or I have predefined column names within that file, and I let read.table know that by setting head equal to T. So head is equal to true. There is a header. There are heads. There are column names. So recognize that. But if I don't have that, it's going to be blah. If I don't have that head equals T, it's going to give me this default crap data frame that's really not very helpful to me. So I'm going to set that equal to head. Head equals to true. And now my headers have been defined. My column names have been defined. Okay, so Nick, what I did is, so right, I have this directory test2 in my desktop where I'm also keeping my scripts. And so I just put that file name there. So it's statemath.txt. And so whenever I went to load that into R, I'm doing read.table statemath.txt within quotes, and then other properties about that file so that R can read it well. Yeah, so if you set that, so I go to sessions, set working directory to choose file, and so I'm in desktop and then test2. And I just save that. So it sets my working directory, and so now R knows to look in this certain folder for a file name. Let me know if that's all clear now. Now you're fine. Larry, don't worry about it. Don't worry about it. Everything's fine. Just let me know, Nick, if you're good, if that makes sense now, if we were on the same page. Okay. All right, moving forward. So I'm going to move down a little bit. All right, so again, this is another stupid thing that I do that I have read in books don't do, and that's keeping your scripts and working files in the same directory. And there's reasons why I do that. One is so I keep everything straight. If I don't do this, I'm going to lose it. I'm going to forget where my files are at, and I'm going to forget what my scripts do and what files they should be running on and where those are at. So I keep everything in the same directory just for me, keeping things straight in my head. And again, it also helps out, I don't have to call out the specific directory. So if I wanted to load a file that's not in this directory, I would effectively have to write out this whole line of the direct path, the exact path of where that file is located in my operating system. But if I keep everything in one directory, I can just set my working directory and then not have to worry about defining the exact path to a file. Again, this is something that I don't know if I should be doing, but this is something I do because it makes my life easier, right? I may not visit something for 6 months and then I come back to it. I'm like, what did I do? Well, everything's in that same directory. I haven't touched it, and I can figure out what I did. Anyways, back to important stuff. So state math. State math's defined. State abbrev recognize. So I do in this raw file, I do have like blank space. So like state abbrev, I have a blank space there, and % at or above, I have blank spaces there. R definitely hates blank spaces for column titles, and I think R kind of hates blank spaces in general in files. And so you recognize that the spaces, so state abbrev, abbreviation has been, that space has been replaced with a period. Same for percent at or above basic. It's been replaced. And so what's nice about this is I can start extracting data from a data frame. So for example, if I want to pull out an entire column from that data frame, what I would do is call the data frame with the $, and then select a column title. So that may be a state abbreviation. And so that's going to pull out this abbreviation column and set it as a vector. Right. So now I've basically extracted that information from this file. Nice. So that's one big advantage. And so I can do that with any file. I can do whatever I want to any of these columns effectively with one command line. So I think I can do mean. God, I hope I'm not making something up. I can do a mean state math on the score. And so that's going to just go ahead and do that math for me and tell me that my median score, my mean score, was 281 in that data set. So the mean of that column is 281. I can also do another function. I think it's col sums. Let's see if I break this. This I may be doing something stupid. Nope. Yeah, I've done something stupid. I may not spend. I'll spend like 1 second on this before I give up. Yeah, I know what it's trying to do. So it's trying to calculate all of the column sums. Sometimes that's useful, sometimes it's not. I forget what I was doing. I forget how that function worked. And so since I have text in this file, text in this data frame, it's trying to sum all of the information in these columns. And it's complaining because it has to be a numeric. I have to have numeric data, right? So that failed, right? Error trusting. Anyways, but I think I can do sum. Yes, I can do a sum of, say, state math $, score, and so that should work. Yeah, that worked. So sometimes that's valuable to create a mean. So for example, I might want to set something to a percent. I'm afraid if I can actually do this. Let's see if my math will work okay. So for example, I have total. So I'm going to define total as the score, the sum of the score. Because also in a data frame, everything is editable. So I can extract stuff, I can change stuff, and I can add stuff. So I can theoretically add this is definitely not applicable to this specific data set, but it's just kind of a demonstration that I can do this. So I can make a new column. And so I can make a new column in this data frame, and I'm going to call it. Whenever I do that, I have to call the data frame first. So that's state math, and then after percent, I can define a new column name. So I'm just going to call it percent. And what I'm going to do, let's see if this will work. Let's see if this will work. I'm going to take my state math means score and divide it by the total. And I think this will work on every row, but I'm not entirely sure. So we're about to see what happens. It got a complaint because my total is not defined. There we go. So now my data frame should be modified. So if I look at state math, now I'll have this extra column that's called percent. And so now each score is defined as a percent of the total, right? So in this specific case, it's not all super helpful, but if you're dealing with other data and you want to, and it's all related to a total population, and you want to know how much of that data makes up the total population, R does that very, very fast, right? We can just calculate a sum of a column, make a new column, call it percent, and boom, we're done. Amazing. And the last thing I'll do with this data frame is I can take only part of it out. So for example, I may have a much, much bigger data frame than what I really want to work with, and I only care about a small part of it. I can use R to just make a smaller data frame based off of stuff I care about with a function called subset. So subset, within subset, I'm going to call my data frame that I care about. And then I'm going to define how I want this data frame subsetted. What I want to do. So for example, I may say I want to only have a data frame with scores greater than, let's say, 300. And maybe it complained. Did this complain? This might have complained. No, it did complain. I don't know. Hold on. I've done something wrong. I don't know what I've done wrong. I may give up in a second. Because maybe I don't have anything greater than 300. Maybe so. Yep, because I am an idiot. That is why. So let's change that to scores above, let's say 250, because that'll actually subset it. Everything's over 200, everything's less than 300. So let's set that to 250. Okay. And so now my new data frame of X is just going to include the states. Oh my gosh. Let me do this one more time. I'm almost there. Say 280. Okay. I'm a failure. No, it didn't. Okay, so everything is above 250, and so now I only have 26 instances, right? So now I basically dropped my data frame by half. So yeah, that did work. So subset the data frame and what column you're basing off of, and how you want to subset that folder or subset that data file. We'll see instances where this may look a little bit better, but this is just kind of an example of how we can extract information from a data frame really, really fast if you know what you're doing. So let me do this one more time. Let me actually have that code in here. So subset. Right. There we go. So math, 26 observations as opposed to 50 observations. We've definitely made this file smaller. Okay. And these are just simple things. If we look at subset, we can do this in any way. So I just picked an example of saying I want to subset this in a way where score is greater than 280. But I could also easily pick out where the states, if there are any states, where the score was exactly equal to 280. And so in computer lingo, one equal sign is usually like to define a parameter or to define a variable, but two equal signs is actually assessing equality. And so, like for example, yeah. So if I just say what I did here, like in this bottom hem, I basically asked R, is 2 equal to 3? I'm not saying 2 equals 3 is like, is 2 equal to 3? And R said, no, these two things are not equal. Kind of another nice built-in function of R, define equality. And so I don't know if there are any states where that will actually be true. But it is true, there are 7 states that have a score equal to 280. Kind of neat. Theoretically, I can also histogram or plot these data as is. So if I'm playing around with this plot function, again, I'm just going to call column names. Let's just do score and then percent at or above basic. Let's just see what that plot looks like. It's going to be trash. It's going to be linear, okay? But right, so we can use plot to just go ahead and plot those two columns. And we're going to see better ways to do this, but nonetheless, just a simple example of using a plotting function to look at how our data might be related, right? So right now we see a nice pretty relationship as you'd expect, because the score, and you'd expect the score to be equivalent to how well your students did and how many students did better than basic. Anyway. All right, the last thing that I'll talk about today is a package. And so another big property of R is the community itself. And so anybody can write a statistics or a graphing package or anything and then make that package that will do something publicly available. And so that's already inherent. There are a lot of packages on the CRAN itself. So CRAN, right, the main website, the Comprehensive R Archive Network. So a part of this, just having this R package, there are also additional packages that we can download from here directly through R. So one package we can download kind of quickly that I'll play with next week is called it's Palmer Penguins, but nonetheless, if I want to download a package that I know the name of directly from R, I'll do install.packages, and then within that package, or within this quote, I'll define the package name. So let's see, Palmer Penguins. Now, this won't work because I've already downloaded. I did this as a test. But Palmer Penguins is a data set that we'll play with more so next week. It's going to complain. It may complain that it's already here. It may do nothing. It's going to try to install. And download it. Okay, no problem. It went ahead and downloaded it for me. Okay, so now that package would be installed. Now, if I want to retrieve the contents of that package and use it, then I would have to call R to read that package, and I make R do that by using a function library. So I'll do library Palmer Penguins, I think. Library. Gotta spell. Palmer Penguins. There we go. And so that's installed. Which means, and so anytime that I want to use a specific package for a script, kind of the traditional thing is to do that at the top. So install.packages is independent of library. So if I just want to install something, it's install.packages. And I'll give you some things to install over the weekend. But if I want to call that stuff, then it will be library Palmer Penguins. And so now, as I run this script, whenever I run this script, all the information that's in place in this Palmer Penguin library, I'll have access to. And so another one, we'll leave it at there. So if I run this, if I have this library penguins, then that gives me access to another data frame called penguins. That's information about different penguins, right? So penguin surveys between 2007 and 2009, and stuff about their bill length and bill depth. Again, this is just a data set that's publicly available that we can play with, and we very may will play with it next week. I feel like I've gone a million miles an hour today. Is there did I lose anybody behind? Are we on the same page, or are we completely lost? Okay, good. Yay. Right, so what we've covered today is just some basic data frame manipulations and installing packages from the R archive itself. And so this changes every year, but the most recent number that I found is 15,000 different R packages available for installing. Right, so almost part of the problem is just finding the package that you want to use, or you may need to use, or has the math that you has the functions defined that lets you do stuff well. Right, because there's 15,000 of them. And so kind of how you find what you need is based off of the scientific literature. Like if somebody uses a package, a specific stats package, I think mass is a kind of a common stats package, you'll see that referenced in a paper. But nonetheless, and that's not the only place where we can get packages from. So there's a whole set of biology-related packages on Bioconductor. And so Bioconductor, yeah, it's similar in sense that it holds packages, but it's independent of the CRAN. So we can search around for specific biology-related packages. I think one that I commonly use is DEC2. Let's see if that's available, right? So Bioconductor DEC2 would be a package that I could install for doing some gene expression analyses. Nonetheless, so between CRAN and between Bioconductor, there are thousands of packages, and even taking it another step further, people will also put their R code on GitHub. And GitHub is just a general repository for code in general. It doesn't have to be R, it can be any generic code, any code, it can be Python, C, or whatever. It's just somebody's going to put it there because that's kind of turned into the generic repository for public code, is to throw it on GitHub. And so we can get data from 3 different places, you know, the CRAN, Bioconductor, and GitHub. But yeah, I think that's all I'm going to do for today. Grad students, I would definitely encourage you to, if you have spreadsheets, to upload them on R and see what you can kind of do with them. All right, see if there's anything that you can figure out if it's easier to do in R than it is in Excel or something else like that. And kind of just in general with computing, like in the beginning, right, it's much slower to work in R than it is to work in Excel. But the better you get at R, you'll be able to do more things and do them faster than what you can in Excel. And that's been my world, is like stop using Excel, start using R, and just get better at it, right? Kind of force myself, like abandon myself from using Excel and just use R to get better at doing these kinds of things. All right, but I'll leave it at there. We'll pick up with this, and we'll advance this. We'll take this another step forward of how we can very nicely visualize data in a data frame. And that's what will be the main thing in next week. All right. Feel free to go, and if you have any questions, I don't know, let me know or send me an email or something like that.